Okay, here are the notes for base n number systems. I had to make some videos for these notes because this material is not covered in the book, so it's not in WebAssign either. So that's why I'm making these videos with these notes. Base n number systems. Okay, I'll try to write legibly. Gosh. Alright, let's start off with base 10. Base 10 is called the decimal system. And this is what everyone grew up with. This uses the digits 0 through 9. So for example, 342, if we recall what that means, the 2 is in the 1's position because it's actually the base raised to the 0 power, which is 10 to the 0 is 1. This is in the 10's position, so this is 10 to the first, and this is in the hundreds position, which is 10 squared. Alright, so that 342, what it actually means is if you take that digit 3 and then you multiply by 10 squared and add it to the digit 4, which is multiplied by 10 to the first, and then add that to the 2, which is multiplied by 10 to the 0, which is 1. Right? And so all of that, 3 times 100 is 300. Okay, plus 4 times 10 is 40. Plus 2 times 1 is 2, which is obviously 342. Alright, that seemed a little redundant. We sort of went in a circle, I guess. But that's because everybody is used to base 10 with the decimal system. I just wanted to show you that because we have to do the exchange to these other systems. Let's start with base 2. Base 2 is called the binary system. Computers use zeros and ones all the time. They use binary stuff quite a bit, like in programming. Yeah, this uses the digits 0 and 1. Alright, only 0 and 1. Okay, so let's look at an example of that, and then we're actually going to look at an example of all the zeros and ones, which will be a binary number, and then we're going to change that to decimal. So let's look at 1, 1, 0, 1, 0. This is base 2. Whenever you write a number that's in a different base, you have to indicate which base it is. So you have to it's like a little subscript down here, write which base it is. Or you could put binary down there if you want to, but let's just put base 2. Alright, just like with base 10, this is actually 2 to the 0 position. This is going to be 2 to the first. This one is 2 squared. This one is in the 2 cubed position, and that one is in the 2 to the 4th position. This is the thing you have to remember, these sort of place values, I guess you can say, to change it back to the decimal system. Alright, so this one in this position actually means, just like we did up there with the decimal system, my computer's acting a little funny. It does that sometimes. Okay, so you do 1 times 2 to the 4th plus 1 times 2 cubed plus, that would be 0 times 2 squared. I'm not going to write that. Let's do this one, is 1 times 2, that was in the 2 to the first position. Alright, and that 0 I'm not going to write either, but that would be plus 0 times 2 to the 0. Alright, so let's figure out how much all of this is. 1 times 2 to the 4 is actually 1 times 16, which is 16. 1 times 2 cubed is 8, and 1 times 2 to the 1 is 2. So if we added all those together, would that be 24, 25, 26? Now this number that we got down here is actually in the decimal system, so you don't want to put base 2. You don't have a digit of 2 or 6 in base 2. This is actually decimal, so if you do not have a base on it, it's assumed to be a decimal number in base 10. Okay, so 1, 1, 0, 1, 0, base 2 in the binary system is actually equal to 26 in the decimal system. Now, those computer science majors that do this differently, it's fine. However you do it, you gotta show me some work or whatever your thought process is, all right, to change these, because you'll be converting them when you do your test. All right, we did decimal and we did the binary system. All right, let me get all the way down here to the next page. We're gonna look at base 8. Put that right here. Base 8 they call the octal system, and it uses the digits 0 through 7. Just like in the decimal system, we don't have it just uses 0 through 9. Binary, you don't have a digit that represents 2, which is the base. It's just 0 and 1. So for octal, we're going to use 0 through 7. Alright. So let's do a number that's in the octal system, and then we're going to switch it back to decimal. If my computer works. Okay. Alright, let's try this one. How about 5, 6, 2. This is base 8. Alright, let's see how that comes out. First thing you do, if this number is in a different base, and what your problems will say are convert this to the decimal system. Alright, this is the number 562 base 8. What you would, whatever your base is, write out those positions. This is the 8 to the 0 position, still like the 1's position. Alright, that's 8 to the first position, and this is the 8 squared position. Alright, so then what you do, what that 5 in that position represents is actually 5 times 8 squared. And you're always adding in between here. 6 times 8 to the first, 2 times 8 to the 0. And all you do, make sure you have your calculator. You can plug that in your calculator. This is actually 5 times 64, which comes out to be 320. And if you have 6 times 8 and 2 times 1, alright. So if you add those up, that's 50, and 320 is 370. Remember, when you're changing it to the decimal system, do not put base 8 on the end of that. That's actually a decimal number. This is actually 370. This is base 10. This is base 8. 562 base 8 is actually equal to 370. I'll show you a little bit later in another video how we will go from the decimal and change it to a different base. We'll go the other way. Alright, I've got one more. This video's been 9 minutes so far. Yikes, I got a 15-minute limit on here, so I'll be able to finish this last system. This last system, if anyone does any HTML coding, then you've probably seen this before. They use the hexadecimal system, which is what I'll explain to you for HTML color codes. You can search that online, then it shows you all these different codes for different colors when you're coding in HTML. Alright, but anyway, this is base 16. The base 16 is called hexadecimal. Alright, the hexadecimal system. I'm really watching my time because I don't know if I'll have time to explain this one. I might have to do it in a different video. Alright, this one uses digits 0 through 9. Notice that the base is 16. Oops, 0 through 9. Plus, it uses A, B, C, D, E, and F. The A represents the digit for 10, B is for 11, C is 12, D is 13, E is 14, F is 15. So the hexadecimal system, we need numbers that represent 0 all the way up through 1 minus the base. So I need 15 different digits. So 0 through 9, that's 10 of them. Plus, you need these. Whoops. Yeah, 0 through 9 is 10. Well, anyway, yeah, we have 0 in there also. So you also need A, B, C, D, E, and Alright, let me stop this one and then I'll show you an example of this in the next video.